Hi, I'm Pakra12 and this is my 100th tutorial, and for today I have chosen the most common question I receive from you, and that is what is UV? And I will try to answer like this. UV is a ruler for a plane. Now let me show you why is this. If you want to measure a line, you need a line, okay? And this line has the units, okay? Now imagine you delete the units and you draw some other units. You still have a ruler, okay? Now for a plane we need a ruler on X, a ruler on Y, and so yeah, this is what we have here, okay? Now let me start from scratch. So okay, let's imagine we have 32 units, okay? So we have a constant chop and we set the grid, okay, or count, doesn't matter, to 32, okay? And then the ruler would be a ramp, and a ramp takes the 32 value for the X and 1, okay? And let's have this mono nearest pixels, okay? Now I will have a null here as I would like to instance some spheres. So let's have a sphere, and okay, this one has a radius 1, so the width would be 2. Let's go with 0.5, okay, and also use a transform, and we scale by 1 divided by the grid, okay? And let's see the geometry, okay? And this takes instancing, and we use this texture with red. And let me split the screen, go with geometry, and yeah, we have this line. And if we make the sphere much smaller, let's divide it by 4 again, they look like units on any ruler, okay? Now if we take this ramp in a flip, okay, and we go bottom left, let's go nearest pixels, okay? And now we use a reorder like this, and let's use a custom resolution. So we go with custom resolution 32 by 32, output aspect resolution, and let's set this nearest pixels, and we want 32 RG, okay? And here input 2 takes the green, okay? Now if we go here and translate the instances on Y by the green value, we have this grid, okay? And every time, I would say every time when we have a cluster like a grid, okay, and the distance between the points is equally distributed, I would say we have an UV. Imagine the army troops when they get into formation. In order to arrange, they need to take the one arm length to the next guy, and also in front. And by doing this, all of them, all the soldiers, they get into a grid formation, and yeah, that is a UV, okay? And we can try to modify the ruler. Let's imagine on this ruler, okay? We delete the values and we put some bad ones, okay? That means our measurements would be broken, okay? And for the UV, it's quite similar, okay? Now, if I use an image, so let's go with an image, this one, and we need the fit. Okay, and yeah, let's go with 32 by 32. Let me go on polygon for the spheres, or we can easily go with the box instead. Okay. Like this. Okay. Because I would like to increase this value 256. Okay, so we have this distribution, but for the image here in this fit, we go with fit outside, okay, and we want to remap, yeah, with this UV. Nothing happened, okay. By the time we modify, we bend, we broke the UV, our perfect ruler, okay, and we can do this with the noise, okay. Just plug both of the inputs from the reorder, and here we go with 0, and let's set amplitude to 0 for now, and yeah, we connect this. The moment we increase the amplitude, our image it's getting broken by this UV, this ruler, which is completely wrong right now. But maybe we want that. So yeah, you can do whatever you want with this, okay. And what if we only want to move couple of them, not broken all of the points, okay. So let's delete this, and let's have a circle like this, and I would like to have it black and white. So like this, maybe a little smaller and not in the center. So I will move it a little bit around like this. And this is a texture with 0 and 1. And when I have 1, I would like to modify the values in and I intend to add them on the UV. And so in that circle area, I'll have a broken UV, and in order to affect only those pixels, okay. Now we plan an addition, okay. Remember, we look at the tips of the vectors, okay. Only the tips. The vectors is the line from the center 0 in this case to every tip. And so if we were looking to this as a vectors, were full of lines, okay. Now, yeah, let's work with the tips. And I would like to have a constant. Okay. And yeah, maybe I'll take the constant from here because I need the constant to be RG. Okay. And yeah, let's set the blue to 0, and yeah, this is 0 and 0. And let's multiply with this. Now, obviously, we get 0 now, and we add everything above the UV. Okay. Now, I will use this add here in a remap also to see what we get. Let me open this. Okay. And let's see. If I increase the amplitude, not the amplitude because we use constant, but and here we have the value for X and for Y. And so I can go like this. You see, those points are moving in a direction of this vector, which yeah, has a 0.04 for the X and 0 for the Y. We can change also the Y. Okay. And let me check. So yeah, this is not mono. Okay, now we're good. So yeah, we offset too much. Okay. Now it seems that when you remap, the direction is opposite. Okay. You see, I go with a positive value, so I move the points up, and my image is looking like it's going down. Okay, so have in mind this and not worry about that. Okay, okay. Now, instead of moving some points in wrong positions, or you know, what is needed to move with precision? Okay, and let's see if we get that. Instead of this circle, I would like to have a single line. So let me decrease this to 32. Okay, now yeah, it's bad as now this fit is 32, which is not so nice, but just wait a second. So now I can go with a rectangle. Okay, and yeah, let me see if I can have this 1 pixel. Okay, so okay. And here it's not 16 pixels, it's maybe 4 pixels. Okay, and this is mono. Okay, now okay, let's change. Let's go with this little line, 4 pixels instead of the circle. Okay, and let's set this to 0. Okay, now it's good. Those points are somewhere here. Okay, what amount it's needed to move those points 1 pixel? Actually, yeah, the width of the pixel we talked in the previous one. So let's try with 0, 0, 1 step. Okay, so what is the value for which these 4 pixels I can move them above the other pixels? Okay, now this value here is 1 divided by 32. Okay, because we have 32 points, and the distance that one point it's traveled to the neighbor is the distance between them. Okay, so 1 divided by the grid, and you get the step. Okay, now let me show you something with remap. If we go with, let's say, 8, okay, so a grid 8 by 8. Now obviously I would like to oh, sorry about it. Okay, I would like to have this fit much bigger, so let me have a resolution here, or res. Okay, and this one is 1280. Okay, now let's set this fit to this resolution. Okay, and yeah, we remap with something which is just 8 by 8, but instead I would like to have this 8 by 8 UV much bigger in the resolution, so I use a fit. Okay, and we go with 1280, and here we good. Let's set fill here. Is not necessary, as our previously texture, the input is square, so we don't need that. But yeah, and now if we remap with this, okay, we only have one color for each square, and that is because in this pixel, for example, this green right here as a value, as a vector value, it is the middle, it is the center here. Okay, and I want to show you something, because my idea was, what if you make some computations with a smaller UV, and then increase the UV? Is that possible? Okay, now this UV right here, it's 8 by 8. We just stretch him to 1280, but as the data inside, we have only 64 values. Okay, and once you have this 8 by 8, which is similar, for example, if we have the UV component, okay, on a bigger resolution, let's say 1280 by 1280, and here we use pixelate, okay, because we can use pixelate. Okay, and if we divide a resolution by the grid, let me do like this. So divide like this. Oh, sorry about it. Okay, now yeah, we have the same UV grid. Okay, but I really want to see if I can use this 8x8 and go into a much precise one, much denser one, with not 8x8 values, instead with plenty of values. Okay, now here it's an operator that I believe every one of us were using it in Photoshop, and that is blur. So look, if we blur this, let's remap with it. Okay, let's go, let's increase this value. Okay, my question is there a value we can plug in and get back the bigger UV, the denser UV? And yeah, it seems it is. So we filter size, it has to be 1. Let me check if it's 1 divided. Not. It's okay. I know which one is this one. Divide by the grid. Okay, and we are not quite there, but I believe it's divide by 2. No, multiply by 2. Okay, now we have the image back. And let's have a look. Let's have a look on this, but as a points. Okay. If we go with the blur to 0, we have the 8x8 points, and while we go bigger with the blur, you see, it's like they give birth to a lot of points in between, because they do the average with the neighbor. Okay, and yeah, and if you use this value, which is resolution divided by the grid multiply with 2, we get almost the initial UV. Where is different is because when we blur here, in between those 2 pixels, for example, the last 2 from the bottom, okay, the last one, it has the value where I have my mouse position here in the middle. Okay, so everything that it's bigger than this value to the 1, okay, it's stretched. Okay, so if we look to the edges of our image, okay, let me change. So this is the blur, okay, and you see the only difference comes on the edges. Okay, so let's have a look here as an image. Okay, this is the blur one, and okay, but yeah, there are several ways of solving that. Okay, because you need to normalize those corners in between 0, 1, and then have a blur. Okay, to not lose that edge. But yeah, and this type of handling the UV with blur, it's very helpful, when you remap images and stuff like that, because the UV is the only texture where blur actually gives you a specific output, I should say. Okay, so let's see what blur does on this image. Okay, so as we saw from a grid 8 by 8, a blur can fill up the whole square. Okay, but what if we blur this? Okay, let's see it as points. Okay, and yeah, let's increase the blur. And yeah, we get something strange, which can have you can use it maybe in doing something visual as an image, or but it's boring. Okay, and when you blur an UV because of the relations between the points, when you blur it, you get very smooth values. And so yeah, this was my tutorial on UV, and I hope you have a little bit better understanding of this tool, and where it's useful. Okay, so yeah, I use it every day, all the time. Anything you do, you will use a UV. Okay, now imagine hundreds or thousands years ago, people build everything with just a line and a compass. Okay, and so yeah, the UV is like you have two lines and a plane, and you can do a ton of computation if you yeah, if you get friendly with this special texture, I would say. This was my tutorial. I really hope you like this. Thank you, Messi, for your support, and see you in the next one. Bye.